A random forest lets many trees vote all at once. Boosting takes a completely different approach. Picture a relay team of trees, working one after another. Each new tree studies the mistakes of the ones before it, and tries to fix them. Here's the contrast. A forest grows its trees in parallel, independently, and averages their votes. Boosting grows its trees in a chain, one at a time. Each tree depends on the last, because its whole job is to correct what the previous ones got wrong. We start with a single, very simple tree, a weak first guess. On its own, it's not very good. It gets a handful of our customers wrong. Those mistakes are exactly what we're going to focus on. So we highlight the points the model got wrong. These are the residuals, the leftover errors that our team still needs to clean up. The next tree will pay special attention to them. Now we train a second small tree, aimed squarely at those leftover errors. We don't trust it completely though. We add only a small slice of its correction to the team, a careful step, not a leap. Added together, the two trees already do better than the first alone. Watch the error meter, it drops. Several points that were wrong a moment ago are now correct. Then we do it again, and again. Round after round, a new tree fixes whatever is still wrong. With each round, the error shrinks and the combined prediction grows sharper. Dozens or hundreds of small trees, each nudging the answer a little closer. That size of each step has a name, the learning rate. Small steps with many trees are careful and accurate, like easing into a parking spot. Big steps are faster, but risk overshooting and overfitting. Slow and steady usually wins. Boosting is often the most accurate method for everyday table data. It's what wins many competitions. The famous libraries XGBoost and LightGBM are just fast, polished boosting. The catch? It's sensitive to its settings, and it can overfit if you run too many rounds. In scikit-learn, we reach for a gradient boosting classifier. We set the number of trees and the learning rate, the two dials we just talked about. Then the same fit and predict, and it builds the whole chain for us. So boosting builds trees in a chain, each one correcting the last, with small careful steps. It's often the top performer on tabular data, powerful, but it needs careful tuning. Next, a very different idea, drawing the widest possible street between the classes.